Before we look at today's lesson, I want to talk about a couple of the problems off of last night's homework that you just passed in to be graded. So on number one, hopefully you noticed that your lateral faces were these rectangular faces, and so the two non-rectangular faces that are triangles are the base. So this is a triangular prism. So you shouldn't have used the 1/3 that you use for pyramids. Now when you go to find the volume, you know that you're going to multiply the base area times the height. Well, the base of this prism is a triangle. So this is the figure that you're finding the area of for the base area. So the area of a triangle is 1/2 the base times the height. Not the same height as what we're talking about in the formula here. That's the height of the prism. So this 4 yards right here is the height of the prism. Remember, the base and height of a triangle have to be perpendicular to one another. So I was noticing some students trying to use the 2 and 4 as their base and height. But when I look at the angle formed by those sides, I'm not given that that's a right angle. So you don't want to use these two sides as your base and height. You're looking for a perpendicular relationship, which we see with this right angle symbol right here. So that means this side of the triangle is going to be the base, which we're given up here to be 5 yards. And so the segment that's perpendicular to it that we have labeled as 1.5 yards is the height. So you should have used the 5 is the base, the 1.5 is the height, and then the 4 yards for the height of the prism. On number 2, we only have one base. The lateral faces are triangles in this figure. This triangle is the base of the pyramid, and so this is called a triangular pyramid. We have the apex up here, so just one base. So remember, when you find the volume of a pyramid, it is 1/3 the base area times the height. So I wanted to remind you that the base is a triangle. So the formula for the area of a triangle is 1/2 the base times the height. The formula for a pyramid means you have this 1/3 that you're multiplying by as well. This is the height of the triangle. This is the height of the pyramid. So this is your volume formula for a triangular pyramid. Looks a little complicated. You have the 1/3 because it's a pyramid, the 1/2 base times height because your base is a triangle, and then this height is the height of the pyramid. So if you wanted to, you could do the 1/3 times 1/2 and just do that as 1/6. That's one thing you could do. Or you could do the 0.5 times everything and then divide by 3 and then change it to a fraction if necessary. That's just up to you what you prefer to do. But don't forget, this base and height of the triangle have to be perpendicular. So when I look at this triangle, which is one of those famous Pythagorean triples, the 3, 4, 5, the right angle is right here between the side that is marked as 3 miles and the side that's marked as 4 miles. So you would use the 3 and the 4 as the base and height of the triangle. And then this perpendicular segment is the height of the pyramid. Okay, and then number 7 on your homework, I wanted to draw your attention again to the fact that this is another triangular prism, just like number 1, because you have these rectangular faces, and then these triangles are the bases. You have 2 of them, so it's a prism. So the volume is the base area times the height. The base is a triangle, so there's that 1/2 base times height again. This is the height of the triangle. This is the height of the prism. Again, the base and height of a triangle have to be perpendicular. So you're not going to use this side that's 3 and this side that's 5 because I don't know that that's a right angle that's formed where those two sides intersect. So here's the perpendicular relationship that I'm looking at. This looks a little strange right here, like this is talking about this whole segment, but I want you to be able to kind of visualize this 3D solid. This is the height of the prism, this 3 yards. And here it is again right here. And here it is again right here. So this 2.5 yards is not from here to here. This 2.5 yards, remember I said things are usually centered along what it's talking about? It's talking about this segment right here. This right angle shows that that is perpendicular to this side of the triangle. So the base and height of this triangle would be the 6 and the 2.5 yards for this segment right here. The height of the prism would be this 3 yards right here. So hopefully that helps a little bit in visualizing those 3 problems from the homework. Okay, so today we're going to be looking at a concept that's called Cavalieri's principle. It sounds a whole lot more complicated than it actually is. And so to kind of visualize what Cavalieri's principle is, I first want to read the principle and then kind of show you in a visual way of what it's talking about. It says, if 2 solids have the same height and the same cross-sectional area at every level, then they have the same volume. So to visualize this concept, I'm going to use a stack of index cards. So these are just index cards that you would use to help you take notes or write a speech on, or different things that we use them for. When I take each one of these cards and I stack all of them on top of each other, just like we did with the circular disc a couple of days ago, I have created a 3D solid. The 3D solid that I have created is a rectangular prism, because the base is a rectangle, and I have stacked that up on top of each other this height number of times. So I've created a rectangular prism. If I wanted to find the volume of this rectangular prism, I would multiply the length times the width of the base, and then multiply it by the height, which is all these cards stacked on top of one another. Now, if I take that same number of cards, what I have right now is what's called a right prism, meaning if I go from the center of this base to the center of this base, I'm going to have a perpendicular segment to the bottom base, right? It's going to go straight down from center to center and be perpendicular with that bottom base. If I take this same stack and I kind of push it off to the side, I'm going to kind of slant it off to the side. Now, did I take any cards away? No, it's the same number of cards. I've just now have created this slanted side right here just by pushing the cards off to the side. So did I change its volume? I didn't remove any cards, so it has the same exact volume. It has the same number of cards stacked up that it did to begin with. So this stack of cards has exactly the same volume as it did when it was a right prism. When I slant it off to the side, it's no longer a right prism. If I connected the center of this base to the center of the base on the bottom, which is here, no longer is that going to be a perpendicular segment. That's going to be at an angle other than a 90 degrees. We call these oblique prisms. If it's not a right prism, it's called an oblique prism. So it still has the same exact volume, and it's because this stack of cards still has the same exact height as it did when it was all stacked nice and neat as a right prism. I didn't change the height at all just by slanting it off to the side. Also, if I cut it at any section along the way, the cross sections are still those index cards, which are those rectangles that the base, both ends are. So it wouldn't matter if it's a right prism, the cross section is that rectangular index card, or if I slant it off to the side, if I cut it and I look at the cross section, it's still that rectangular index card. So that's all Cavalieri's principle is saying, is that if you have 2 solids that have the same height and the cross-sectional area is the same at every level, they're going to have the same volume. So that means if you have a right prism or an oblique prism, as long as they have the same height and the same cross-sectional area, they're going to be congruent in their volumes. So let's look at a picture here and see if these 2 cylinders would have the same volume using Cavalieri's principle. Now this first one is what we would call a right cylinder. If I connect the center of this circular base to the center of this circular base, that would create a perpendicular segment to the bottom base. The radius is 2, the height is 4. If I cut that cylinder parallel to the base and I picked it up and look at it, it's going to be that circular, same circular shape as the bases are, every single level. If I cut it here and open it up, cut it here and open it up, cut it here and open it up, I'm going to open it up and see a circle. This one, as you notice, is not a perpendicular segment from center to center anymore. If I connect the center here to the center here, that's no longer going to be a perpendicular segment. So again, this is called an oblique cylinder, meaning it's been slanted over, is all that means. So it still has the same radius, 2 inches. The 4 inches is given for this segment right here, which they're just showing that that's perpendicular to the base there, showing you an altitude length. And so since they have the same height and the same radius, meaning that circle has the same area as this circle has the same area as this circle, if I cut this at any level, it's going to be the same circular area. That means these two cylinders have the same volume due to Cavalieri's principle. This one's been pushed over, it's been slanted, but it's the same exact cylinder, it's just been pushed over. The height and the base are the exact same thing. So that's all Cavalieri's principle is saying. So here it is again, the same visualization I gave you is given with a stack of books. Okay, here's a stack of books so that the center at the top to the center at the bottom would create a perpendicular segment. If we take the same stack of books and just slant it over, push it over, we didn't take any books away or add any books to it, so we have the same volume. Even though if I connected center to center, it wouldn't be perpendicular any longer. This is an oblique prism, whereas this is a right prism. But the volumes are the same because the height is the same. You see, this is just as tall as this stack. The area of the bases would be rectangles. They're the same book, so they're going to have the same area. So those two stacks of books would have the same exact volume. All right, now this is a couple of examples we're going to look at, and you're going to have to be careful on problems like number 1. It looks very similar to the problem that we just looked at, but I want you to notice a difference between these two drawings. So this is the one that we just got through saying that they had the same volume according to Cavalieri's principle, and these are the ones that we're looking at now. Do you see a difference? So this cylinder, the 4 inches, is giving you this length. This 4 inches is giving you this length. So we talked about what this is called yesterday. Remember, this 4 inches is called a slant height. This is not the slant height. When we're talking about Cavalieri's principle, we're talking about the perpendicular heights of the two cylinders have to be the same. So if I drew in this altitude in this cylinder right here, if I drew it in right here, would this also be 4 if this is 4? Well, they can't both be 4. If you think about this as a right triangle, the slant height is the hypotenuse of this right triangle. We know the hypotenuse has to be the longest length. So that tells me that the perpendicular height would have to be less than 4 inches. So even though these have the same radius, they don't have the same perpendicular heights. This one's 4 inches and this one is something less than 4 inches. So no, these two cylinders would not have the same volumes by Cavalieri's principle because they don't have the same height like they did in the example over here. All right, you're going to have some problems on your homework similar to number 2 here on the example here. It says a cylinder is removed from the center of a large cylinder as shown below. So this unshaded part is a cylinder. It goes all the way through. It's kind of like a toilet paper roll if you'll think about that. And then the shaded is a big cylinder but with that empty part taken out. So exactly like a toilet paper roll. So we are told the radius of the cylinder that was removed, so the empty part, is 3 inches. So this length right here is 3 inches. The radius of the large cylinder is 6. So the center of the large one is the same center as the small one that was removed. We're talking about this radius from the center to the out part here that is 6 inches. You're told the height of the solid is 12 inches. You want to know the volume of the solid that remains, so the shaded part. So you're going to have to find the volume of the large cylinder and subtract out the volume of the small cylinder. Now, both of these, we know we can find the volume of a cylinder by looking at the same thing as we do with prisms, since they both have two bases. Remember, we're going to find the volume by finding the base area times the height. That's how you find the volume of a cylinder. Since the base figure is a circle, the formula is going to be, the volume is pi r squared h. Now both cylinders, the large one and the small one, are going to have the same height. So the height for both of them is going to be 12 inches. But the radius is different. For the small one it's 3, for the large one it's 6. So I'm going to start with the large one, and I'm going to write the volume is pi times r squared, which for the large one it's 6, so 6 squared, times the height, which is 12 inches. And we're going to subtract out the volume of the small one at pi r squared h, but this time the radius is 3 and the height is 12. Remember, we're not going to be rounding, so we're going to put everything in our calculators if you have one. If not, you can do it off to the side here. 6 squared is 36, and 36 times 12 is 108. So we have, I'm sorry, that did the wrong one. 6 squared is 36. 36 times 12 is 432. I'll get it right. So this is 432 pi. Now the small one, 3 squared is 9. 9 times 12 is the 108. So we're subtracting 108 pi from 432 pi. Since both of these have a pi, then that means they're like terms and we can subtract them. So 432 minus 108 is 324 pi. Remember that pi doesn't cancel out. If you have 5 apples and take 2 apples away, you have 3 apples, not just the number 3. So 324 pi, our units were inches, so this would be inches cubed. So that's the volume that remains after we do the subtraction. All right, so you have a couple of problems on your homework tonight. You need to read number 1 really carefully. Make sure you make the conversion to pounds the way it tells you to. That's how your answer should be given, is in pounds. So good luck, do well. I'll have tutoring in the morning at 7:30 if you want to come and get your homework answers checked. All right, have a good day.